In this 15 minutes Turbonomic demo, we were focused on the value propositions, the technology and architecture, the user experience through demonstrating the use cases. The content. In the first 5 minutes, we go through the slides on Turbonomic overview. We will compare the reactive and proactive approaches for application resource management. We will go through the core technology, supply chain market model. We will introduce the Turbonomic value propositions and the demo use cases. In the second part is the demonstration. We will show how Turbonomic takes the top-down approach to assure that your applications get the resource automatically. There are two personas. Mark is the site reliability engineer manager. He managed his team on overall enterprise resource operations. The second persona is Eddie. Eddie is a site reliability engineer. He managed the resource of his assignment, his assigned applications and projects. First, let's compare the reactive and preventative performance management models. Most enterprise apply the reactive application resource management model. Basically, reactive ARM is based on the monitoring alert. Whenever there is an alert, a performance complaining, a billing alert, for example, AWS bill is a spiral up. Why? The stakeholders and the related teams will get together to look into the problem. For example, the operation team, application team, FinOps team, and some management and executives were involved. They will look into the system one by one and understand the system and understand the data, understand the monitoring, the issue, and conclude what is the problem. There is major pain points on this reactive ARM model. First, lack of the full stack resource visibility. Second, the APM tools cannot assure application performance preventatively. Third, resources are usually over-provisioned for assuring the application performance, which is the waste and potentially are cost-saving opportunities. Now we look at the preventative application resource management. Turbonomic go with the preventative ARM. Turbonomic with its patented algorithm is called supply chain market model. It do two things. First is analyze the environment, analyze the data from the APM from the cloud, and create the reliable actions based on the analyzed insights. The VMs, volumes, DBs, containers, and applications receive or remove resource by these actions. If the asset has received the resource, a problem has been prevented. If the asset has reduced the resource, the IT has eliminated a waste, which is the cost-saving opportunity. So the advantage of the preventative ARM is very obvious. One, it provides the full application supply chain visibility and insights. Second, it assures application performance with the cost efficiency for both on-prem and cloud by automating the resource actions. For on-prem, it eliminates the cost of the performance issues by optimizing the existing infrastructure. For cloud, it unlocks the cloud elastic features by allowing the customers to pay exactly the needs to avoid over-provision. The code technology make the preventative ARM possible is the supply chain market model, which is the patented technology of Turbonomic. A top-down approach to assure the application to get resource automatically. First, supply and demand at every level of the stack. Second, generate the actions reflecting their effects up and down the stack. Third, continually and safely drive the data center on-prem and in the cloud to a desired state. If you see the diagram from the left, that is the full stack of the supply chain. We are using the virtual machine layer in the box as an example here. On the top of the virtual machine, their demand, the application, different kind of applications running on the virtual machine, demanding on the resource. Below the box, there are suppliers. There are infrastructure providing the resource to support the resource demanding from the application sides. So this model is really based on the balance between the supply and the demand. And the third parameter introduced here is the compliance policy. So three things: the demand, performance demanding, and the cost efficiency for the supplier, and the compliance of the policy. And in the right side of this diagram is very important to use the turbonomic. So for each entity, for example, the virtual machine, there have the different colors to represent the status. If the color is green, which means it's ideal status, the resource is allocated properly, optimizedly configured. If the color is yellow, it means it's being over-provisioned the resource. So there is a cost-saving opportunity by scale down the resource. If the color is red, it means it has the performance risk and demanding more resource allocations. And this kind of diagram is dynamically changing because the actions is dynamically created and executed. This slide introduces the value propositions and architectures of the turbonomic. The value proposition is very clear. It's being the three. One is ensure the performance. One is eliminating the cost, eliminating the waste, the cost-saving opportunity. And number three is adhering the compliance the business policies. And in the diagram, there are 4 steps to implement the value proposition. The first step is collecting the data is based on the agentless API-driven discovery. So collect the data from the APM, collect the data from the cloud, and to get the insights of the environment and the performance. And the second one is the supply chain model to stitch the information together with the different layers, which including the application layer, including container, virtual machine, and the infrastructures. So these layers get together and to reflecting the application or even the overall enterprise, the resource management. With the step 1 and step 2, the information and the trustworthy actions can be generated. The action including the intelligence actions, intelligent sizing, continuous placement, dynamic scaling, and start and stop. And all these actions can be configured to the different kind of the automations. It can be executed manually, executed in real time automatically. It can be scheduled to execution, or it can be integrated with pipelines and workflows such as ServiceNow. In the right side of this slide is the return on investment for the enterprise to adopt the turbonomics, 33% reduction in the public cloud spending due to the dynamic scaling and workload resizing, and also improve the infrastructure utilization and avoided the annual refresh cost by 75%. And by understanding the app demand, avoided the required infrastructure growth spanned by 70%. So in this last page is demo use case. The Turbonomic is a core asset for the operation team or site reliability engineering team. The team is typically to manage the hybrid environment of the overall enterprise, which is including the on-prem systems, data center optimization, and the different cloud, the cloud migration, continuous cloud optimization, and sustainable elastic cloud, which including AWS, Azure, and Google. And there are two personas are using the Turbonomic. One is Mark, is the manager of the team, and he wants to understand the full stack enterprise applications overall as an enterprise. He wants to use the application resource management to understand the insights of the business applications, business transactions, and the service, and to identify the risks and cost-saving opportunities. He also wants to understand the insights of the different platforms like on-prem, cloud, and container platforms. The other persona is AD. AD is application side reliability engineers. He wants to understand the full stack insights of the specific application he's assigned to him. And he wants to prevent the resource incident and preventatively through the action automation policies. And he also wants to plan the cloud migration based on requirement. Let's take a look at the demo environment to see how these use case being implemented. This is the Turbonomic demo environment and already been set up to monitor the enterprise. And this enterprise actually can say this is the main page, including the supply chain of the overall enterprise, which including the 44 business applications. And from the top down, you can see the business applications, containers, virtual machine, and the host, and even to the data center, to the zone, and to the region. So this is really including all the information from the infrastructure perspective and from the resource management perspective, and bring the Mark overall picture of the situation. And also for every node, the different color shows the red means the risk of the performance, and the yellow means the opportunity of the cost saving, and the green means the situation is in ideal status. And the Mark also can see the widget. So the top business applications, and it's sorted to be the, if you have the risks, it's always pop to the first one. And if you can click show all, and then you can see all the 44 applications here. And similarly, he can view the top business transactions or the top service just from the first pages. And also he can go to the dashboard to see the insights from the platform perspective, for example, on-prem, cloud, and container platform. For example, he can go to take a look of the cloud dashboard to see the insights of the AWS, Azure, and Google, and see if the environment is being optimized and managed. The other persona is AD, is the engineer. AD is interesting the application assigned to him. For example, the first one, which has maybe have some risk because it's assigned to AD to optimize. AD can click and look into it and to see this is the supply chain of this specific application. It's called the mobile banking transfer application. And then you can see the infrastructure to support this application and the host and the virtual machine. You didn't see the container, which means this application is running directly in the virtual machine. It's not the container not on the container platform. And also you can see the color in red, which means there is the resource actions need to applied to optimize the system to eliminate the risk of the performance. And you can see the actions being automatically generated. So what AD really want to do on a new application is to set up the policies. The policies is very easy to set up. Just go to the setting and go to the policy, and then he can set up the new placement policy or new automation policy, and based on the needs. For example, in this case, this is the virtual machine, and then he can configure the scope, the policy schedule, and automation and orchestration, action constraints, operation constraints, and scaling constraints. After set up all these parameters, and the actions is going to be automatically generated and executed as configured. Okay, and the last use case for the AD is to the planning, the cloud migration. There is a planning menu here, and then he can use the new planning and migrate to cloud. And for example, he want to migrate from the on-prem. He can select whatever cluster he want to migrate, and then next to migrate to whichever cloud, Azure, maybe EA development, and select a region, and add the license preference. In this case, maybe he can use whatever license purchased from the Azure, and then he can set up the reserved instance, which have another opportunity to save the money and can get 1 year or 3 year, maybe reserve for 1 year and run the plan. It's only about a few seconds, and the plan can generate it, including the different options to migrate to cloud. As you can see, including the lift and the shift options, which means do not adjust the size of the resource, like virtual machine storage, the memory, or the Turbonomic have the recommended optimizations here, and I can compare with the price. You can see the total cost for the lift and shift is slightly higher than the optimized. And then this can help a lot for an SRE to operate with the different cloud. So as the SRE, he do not get the in-depth knowledge of the specific cloud like Azure or AWS. Instead, they just understand how to operate the Turbonomics. Then all the cloud he can operate and manage. This concludes the demonstration of the use case of the Mark, which is the SRE manager, and AD, which is the site reliability engineer. Let's go back to the conclusion page. So in conclusion, in this Turbonomic demo includes the full stack visibility for application to infrastructure, both individual application or the overall enterprise for the SRE or SRE manager. The resource optimization actions in real time based on performance, cost efficiency, and compliance with the automation policies. Planning the cloud migration with Turbonomic plan. If you are interested to Turbonomic based on this introduction demo, we can plan the next steps. We can plan the proof of value session to apply the Turbonomic to your environment and your setup. And also we can plan a lab service and garage engagement discussion on the service needs. And also we can set up number of the deeper dive sections with the technical influencers on the development, deployment, and setup, and ecosystems, integration with the ServiceNow, integration with the APM, ITAM, and FinOps. And we also can deep dive to the supply chain market model. This concludes the demonstration of the turbonomics. Thank you.